Hello, Year 11s. So the last lesson, in fact, the last lesson of the GCSE syllabus, is going to be on Redshift and the expansion of the universe. So I was just going to spend a few minutes just explaining what it is that you have to learn. Then I'll show my homework. I'll point you to some resources for you to have a read of. You can also take some notes, and we'll give you a homework sheet to do, which I would like in by Sunday evening if possible. Okay, so first of all, what is Redshift? Redshift is when you have an object producing waves of light, and the object is moving away from you. Now, when the object is moving away from you, the waves of light get stretched out, so the wavelength, the distance between the waves, increases. Now, what happens to light when the wavelength increases is that the light becomes redder, hence the word redshift. The opposite to that would be blue shift. If you've got something producing light that's coming towards you, its light will get bluer. Now, why is this important in the context of the universe and the evolution of the universe? Well, in about the 1920s, a very famous astronomer, Edwin Hubble, discovered that all galaxies, or pretty much all galaxies, there's a couple of exceptions, are redshifted, which means that when you look at the light that's coming from galaxies, it's always redder than it should be. That means that these galaxies are all moving away from us. And not only did he discover that, but he discovered something even more interesting as well. The further away the galaxy is, the more distant the galaxy is, the more redshifted it is, which means the faster it's moving away from us. So nearby galaxies moving away from us at a fairly slow speed, more distant galaxies moving away from us at a very fast speed. And this applies in every direction that you look all over the sky. These galaxies, which are huge distances away from us. Now, remember, in the last lesson, I explained what a galaxy was. It's a huge system of stars, billions of stars. The Milky Way is our galaxy. Now, a galaxy is usually about 100,000 light years across, so it's absolutely massive. These galaxies beyond the Milky Way are millions and millions of light years away. But when you look over that distance across the universe, you see in every direction these galaxies appear to be moving away from us. They're redshifted. Redshift, by the way, is a very similar effect to something you might have heard of, which is Doppler shift, which is if you've ever stood by the side of a road when an ambulance goes past and the siren's blasting away, you'll notice that the pitch of the siren changes as the ambulance goes past. When the ambulance is coming towards you, the siren will have a higher pitch. When the ambulance is going away from you, it'll have a lower pitch. That's because the sound waves, just like the light waves from these galaxies, get squashed if the object is coming towards you, and they get stretched if the object is going away from you. Longer sound waves is a lower pitch sound. Shorter sound waves, a shorter wavelength, is a high pitch sound. Same thing with galaxies. If they're moving towards you, the light gets bluer. There's only one or two galaxies that actually do that. The vast majority, billions and trillions of galaxies, are all moving away from us, and they are redshifted. And the further away galaxies are, the more redshifted they are, and the faster they're moving away from us. Now, what's the explanation for this? Why does it seem like everything's moving away from the Milky Way in the universe? It seems quite a sort of mysterious idea. It almost looks like we're at the centre of the universe and we occupy a special and important position in the universe, and everything's moving away from us. Well, actually, that's not true. The solution to this idea that every galaxy is moving away from us really comes from the idea that as you get further away, the speed increases. Now, there's only one convincing explanation for this, and it's kind of a strange one, really, but the space between us and the galaxies is actually expanding. We normally think of space as being a very sort of dull, boring thing. It's just sort of stationary. It's not doing anything. If you've got a certain length of space or a certain volume of space today, it will be the same volume of space tomorrow. But in fact, that doesn't appear to be true. The volume of space over time, even if you do nothing to it, just expands. And so distant galaxies, because they're so far away, will appear to be moving away from us. Obviously, the further away a galaxy is, the more space there is between us and the distant galaxy, and therefore the faster it's moving away from us. So this led to the idea that the universe itself as a whole is expanding, or space is expanding, which is kind of a strange concept, really, although some scientists had already predicted that that might be a possibility, Albert Einstein being one of them. Now, one of the conclusions that came from this idea that the universe was expanding was a theory that you'll have all heard of, which is the Big Bang. Now, the idea behind that comes from this idea. Well, if you go forwards in time, the universe expands. But if you wind time backwards, if you can move the clock backwards, the space between galaxies will actually get smaller. So space shrinks over time if you go backwards in time. If you go far enough back in time, and we now think about 13.7 billion years, which is about 3 times the age of the Earth. If you go far enough back in time, the space between the galaxies actually vanishes completely. And all the matter in the universe and all the energy is compressed in a very dense and very energetic, very high temperature state, which suggests that the universe has a beginning. It started off in this very unusual state of an incredibly high density and an incredibly high temperature. And from that state, it expanded and cooled down and became the universe we know today. So that early state of the universe, that beginning point, if you like, is called the Big Bang. Now, there is other evidence for the Big Bang apart from the redshift of galaxies. And that's how scientists prove theories are correct. They look at the evidence that's available, and they find the model that best fits the evidence that they've got. And as far as we can tell today, the Big Bang theory is the best theory for the origin and the subsequent evolution of the universe. That's not to say that there aren't still things that are unexplained or unknown. You may get general questions on a GCSE paper, if any of you sit a GCSE paper at some point in the future, which relate to asking you what a scientific theory is, and why scientists will prefer one scientific theory over another. And it's all about evidence. And if a theory fits the evidence or the observation better than a previous theory, then the previous theory becomes superseded. So the Big Bang is the current best model for how the universe started and evolved. As I said, there are things that are unexplained. If you ask a cosmologist what happened before the Big Bang, some will say it's a meaningless question. Others will just not be able to answer at all. There's a lot of unknowns about the Big Bang. There's also a lot of unknowns about how the universe itself is expanding. In the last couple of decades, there's been some more studies that have been done on the expansion of the universe, which has shown that the universe itself isn't expanding at an even rate. So if you look very far back to very, very distant galaxies, they're actually speeding away from us much faster than they should be, assuming that the universe was expanding evenly. And that suggests that the universe is actually accelerating in its expansion. And scientists have come up with a theory. It's called dark energy, which is a very mysterious entity, which is somehow pushing the universe apart at a faster rate than the universe should be expanding apart. Unfortunately, nobody actually knows what dark energy is. There's lots of suggestions and theories, but none of them quite fit the observations. There's another mysterious entity in the universe called dark matter, which is required to hold galaxies together. Galaxies, as I told you before, are made of stars and dust and gas. But if you actually look at the gravity that's holding galaxies together, it can't just be explained by the stars and the gas and the dust that you see. There's something invisible that is holding galaxies together, which produces gravity but doesn't interact with anything else. And we give this the name dark matter. And just like dark energy, dark matter is a complete mystery. We don't know what it is. There's lots of theories, and there's a Nobel Prize out there somewhere for somebody who discovers exactly what dark matter is. But at the moment, it is a mystery. So that's pretty much what you've got to learn about in terms of cosmology and the universe as a whole. It's a big topic, but it's only a small part of the space physics and the GCSE. You basically have to be able to explain what redshift is. It's the increase of wavelength of light emitted by something that's moving away from you. And you have to explain how that led to the idea that the universe is expanding, because galaxies are moving away from us at a faster and faster rate the further away they are, and how that leads on to the idea of the Big Bang as the beginning state of the universe. So that's basically it. As I said, this is the last lesson on the curriculum that we're going to cover, and I'd like you to get the homework in by Sunday. The next thing I will be giving you will be a small end of topic test for you to do at home under exam conditions if you can manage that. And that's pretty much it. After that, we'll just be doing revision over the last 2 years or 3 years worth of GCSE work. Okay, thank you very much for listening.